but welcome to JavaScript Girl in a .NET World. Today with me, I have two beautiful guests. We have the lovely FuleSnabel. Is it FuleSnabel? Am I saying that right?
But it's a troll name anyway, so...
Is it?
FuleSnabel.
Is it Schnabel?
Snabel is kind of the thing. It's a joke name. And worst of all, it's a kind of a joke between some of my friends. So it's even worse than a normal joke. So yeah.
Private joke.
Hey, yeah. Napalm, good to see you. And then also the beautiful Layla codes it yonder. You would not believe how hard it is for me, Martin, to like remember that you are Fuel. Like, because to me, like I have this picture of who Fuel is, like from the chat and from talking with you online. And so then I talked to Martin on Twitter, and I'm like, it's like really hard for my brain to connect the two. So I'm super excited.
He's much nicer, this Twitter guy, than this Twitch guy. Twitch guy is obnoxious. Nobody likes him.
No, but
yeah, I'm kind of a little bit schizophrenic.
I am so excited. You have been on so many of my Twitch streams, and you always support the channel. So I'm super excited to have you on today, and I wanted to let you have a quick introduction. Can you tell us a little bit about yourself, what you do, where you are in the world?
Well, I'm in Norway, but as some know, I'm a Swedish person living in Norway for the salary, because Norway pays twice the salary than in Sweden. So that's why you live in Norway as a Swedish person. And currently, I'm migrating kind of an application from Cobalt into C# and web and sort of what we might say modern technology. So,
I didn't even know that was possible. Like, is it an actual migration, or is it?
We are rewriting software from the beginning of the 1980s. Well, to be honest, Napalm is not that bad. The old Cobalt code is quite well architectured, and the data scheme is quite good as well. So it's a quite interesting prospect. We have more. The biggest problem we have is not the Cobalt code. We have much more the normal kind of problems, if you say so like that. So like deadlines and all these kind of things. And so that's my day job currently. But I have been working. I've changed. Well, not within computer science. I've changed career quite often.
Yeah.
I'm not sure that's a good idea, but I have done it, and I usually switched. I've been a front-end developer when WPF was hot and cool. And I thought that was brilliant and never wanted it to change. And then that kind of died. It didn't die, but the JavaScript kind of came over and took over the world. So in kind of an embittered move, I'll say, screw this, I'm going to go embedded. And then I became an embedded developer at Ericsson.
Have you heard of embedded, Layla? I didn't know that.
That's kind of low level. So
is it Microsofty, or is it its own thing?
No, not really. But your telephone, to give you an example and not take too much of your time, but your telephone talks to something called radio base station, and the radio base station has a lot of software running on it, and that's typically called embedded software. I'm not sure that's a good idea, but it's or a good description, because it's a very complex machine. But sometimes you talk about embedded when you talk about IoTs, these Raspberries and so. But usually you don't have that much processing power, and you have to think about timings, and often written in C++, or tools like that.
That's like a weird jump to make, right?
Yeah, of course. I was so bitter. And then I decided to move to Norway, and then I did big data for a few years. Until that got boring.
How does one do big data? I imagine you just like writing SQL queries. Like, no.
Well, I managed a data lake in S3 that was one petabyte big, and I dealt with a lot of
petabyte. Oh my god!
I know. I'm like, I can't even comprehend a petabyte, but okay.
Yeah. And the backup is also 1 petabyte, so it's quite big. So and. So the challenge with big data is different than other challenges. But we had the problem that all the websites, like the big newspapers in Norway, Sweden, Scandinavia, they were just hammering us with data. We had like trackers, and we were collecting data and sort of storing them in our data lake. And if we went down, they will still hammer us. So it will just build up a huge backlog, and we processed a few terabytes per day, and a few 100,000 messages a second. And compared to Facebook, this is small data, but compared to Norway, I think we quite big data. I'm not sure that's a good answer, but it was like 24/7, standby, and sort of, getting incidents, and also I might not tell you, but I might have had privacy incidents. And, and I might be on first term with the data privacy officer and the chief security officer at that place. So the Christmas card list, and that's exciting when a lot of big bosses in the meeting talking about how do we deal with this. And then I switched to Cobalt. Seemed like a...
What the heck? This is my thing. Like, how do you just switch? Like, do you have...
I have this delusion that I can probably handle anything.
I know, but I'm imagining during the interview, and you're like, yeah, I was doing...
How hard can this be?
I was doing big data. And they're like, oh, this is a Cobalt job. And you're like, yep. Like, I don't... How do you get that job? Like, without having any experience with that stuff? This is just fascinating to me.
So but to be honest, the jobs I tend to get without, so just stop me if I'm getting boring, but it's where they are looking for a generalist, like a person that has, can probably jump in the build pipeline, can probably jump in the sort of deployment, deployment pipeline, can do unit tests, can do that. And I kind of think, I can probably manage that. I'm not the best in the world to do it, but I can probably figure it out. And also, I'm quite old now, so comparatively. So I know a lot of people. So and
I honestly, that's like, sadly, the easiest way to get a job. I don't know if this is how it works for you all, but like, if you have an in with someone, it's so much easier than, even if your resume is stunning. I don't know. It's I guess the way the world works. I don't know.
I can give you a pro tip on how to be better at nailing interviews.
Oh my gosh, yes. Tell me right now.
Yes, and I shouldn't tell you, but but that is, if you are at a company, engage in the interview process, because you will see mistakes that the interview makes. And I was thinking, boy, I could have made that mistake and look really stupid. But at the other side, you don't realize kind of what the blunder you made, kind of, or whatever. Yeah. So you become much better at playing this game, at sort of, dealing with that. And you understand what is happening behind the scenes and how they're talking about your employee. And you're just much better at presenting yourself. It's cheating.
I don't know about you two, but I am absolutely just disgustingly horrible at technical interviews. It's the same with like tests in college, like standardized testing, absolutely horrible at it. Like,
but I think now this is getting close to maybe boring, but I think it seems to me in the United States is well, I have a long list there, Tyndall, so it's not a problem. In the United States, it seems to be very important with these technical tests and how sort of algorithms and these things. And I'm getting so annoyed by that. So luckily in Norway and Scandinavia, I think there are some testing on that thing, but it's a lot less focused on dynamic programming. I don't know what dynamic programming is, so I cannot define it on the spot. So I would I don't think that's so valuable.
Yeah, I've been through a couple of interview processes where, like, one was for an Angular developer advocate position, and I had to. I don't have a degree in computer science. Like, I have a degree in web development, and I don't know if you all know this, but they're like two different things. And my whole interview process was like whiteboarding algorithms, and
and here's another thing which annoys me to the end of it, right? So you are doing all these algorithms and you are grinding to nail this stupid algorithm interview, and then you come into the job and someone says, "Here's a cloud formation template or an ARM template or sort of YAML file. It doesn't work. Make it work." And you go, "Okay, should I apply breadth first search or should I do what? What are you talking about? Just debug it and Google it. That's what you do." So these technical interviews, I think they are
like a memory test.
It is. Yes, it is, Layla. And for someone who got a really bad concussion in my teenage years, it's a little unfair.
Explains so much.
We are part of
Layla.
that dream.
So Martin, you were telling us your history, and you got a Cobalt position. Is that this current one, or is this?
But I'm not really a Cobalt developer guy, but I'm helping out transforming this old Cobalt application into a web application. So my days are normally C#, but reading some Cobalt, reading some database schemas from Cobalt code, and transforming. A big part of before Christmas was taking an old database from the old Cobalt application and tweak it and sort of fix certain things and force it into the schema of our database and pray it works.
Okay, can someone do a real quick definition of COBOL? It's like in my head, people
It's an
cringe
IDE.
when other people say it, and that's all I know about it.
I mean, it probably means many things, but what it means in our case is there's a special dialect of Cobalt, which is a language which has a reputation of being quite much text you have to type. But together with this Cobalt is also an IDE, which actually is pretty good for being from the 1980s. So you can, it's actually very productive when you know what you're doing. I don't know, but I've seen the old guys, the 75 years olds, because I'm working with people that are 75 years old. So that's great, because now I'm kind of the youngest guy in the office again. So this is brilliant.
I was told by a friend that if I wanted to make money as a developer, to learn COBOL.
I'm not sure that is so true anymore.
Is it not? It's not true?
I looked at the Stack Overflow, and the Cobalt guys didn't rank very high anymore. But maybe, as a VB6 programmer, you can make a lot of money these days.
A classic can.
Speaking of legacy, one of the reasons, sorry, I'm jumping in here. One of the reasons I talked a little bit with Alyssa here about a stream together was that sometimes at the stream, someone says something, this is Win32, or this is ActiveX, or this is, what is this main method? And then Alyssa goes, what is this? And people say, no, legacy, let's not talk about that. But I want to kind of, what I thought we could do here, but maybe you don't agree, but we could sort of talk about that.
I do. I want to. And I also am excited to, I wonder if a lot of people say that, because one, it, might not be something that people are commonly using right now, but two, because they just don't know it. And so it's an easy way of like skirting, like, let's not talk about that thing that I just ignore.
I think it's also a little bit that you kind of started here and you got into some kind of clunky old application and sort of your first software, and you never really understood the tooling, and you just had a lot of problems. And then you when you started getting into a seniority level, you migrated into .NET, and this is a new environment. You are suddenly as good as anyone else, or even better, sort of, because you are embracing these things. So in this, you go from an environment where you feel like, I don't really know what I'm doing. I'm just paraphrasing, to an environment where you are the king. Of course, you want to forget that old bullshit. That was bad, because .NET is brilliant. And
honestly, I've had nothing but fun. I don't get why people cringe when I say that, but you got to understand, I hang out with a lot of JavaScripters, and they all give me weird looks when I'm like, this has been pretty fun. And they're like, I don't know. I am not sure why.
Yeah, but they have the same stories, right? Oh, I was working on some old C# application and sort of rubbish code base, and JavaScript is just brilliant.
Yeah. No, Thindle was saying, I miss my WinProc.
Yeah. Here we go.
Is that how you say it? Wind?
I would say WinProc, but probably wrong. This
is it
WinProc,
a console thing?
Shall we already start talking about stuff?
Yeah. Teach us all the things.
So this is how you build old Windows applications. Yeah. But I think WinProc, Findal, is the handle, the pointer type. But anyway, so the way all Win32 software worked, Win32. So if I say things you are not familiar with and you want to talk about it, you just stop me. So we can talk about
I only recently learned the difference between like Win32 and that's the same as x86. And then
I think it's a little bit fussy, but
x86 has never been uttered before to me.
It has not? You have never
No, is
seen
this
it?
this is the same? It's like a synonym? No.
I'm not sure, but it could be. It could be thought of like that. But I don't know. Win32, I think, kind of means Windows, but I'm not an expert on this thing. And this is also one thing I want to point out. I know a lot of junk about COM, ActiveX, C++, but I don't know any kernel mode. The computer science domain is so huge these days. So there's no chance to learn something, because if I spend an hour to learn something, we have added 1,000 hours of more things to learn. So I can never learn everything, and so I have to learn a little bit of the universe, which is embedded low-level stuff in Cobalt. But Win32, it was the old way of writing software, and that is actually quite tied to Windows Forms. So Windows Forms, as some people point out, is actually kind of a thin layer on top of the old way of Win32. So when I was starting working, what was hot those days was MFC, Microsoft Foundation classes, something like that. And this might traumatize some viewers, by the way.
MFC.
But just mentioning MFC. But that was the framework that you built sort of world-class Windows software with before. And then Windows Forms came with .NET and kind of different paradigm. But one thing that MSC does and old Win32 does is that you have something called a message loop, and that is called the WinProc. So when something happens, like you move the mouse cursor, you call that callback, like this callback function, if that makes sense to you, like in JavaScript. You call the function the mouse moved.
Yeah.
But you call the same function when some of the mouse is clicked. So you have a huge switch statement so often. Like if the mouse moved, do this. If the mouse moved, do that. Mouse do that. So
this is all within the system, though. We're not like going out to an API with these events.
Yeah. And this is typically inside the application. So you have like a switch statement that receives these things, and then you might talk to APIs. Sort of, when you click this button, okay, then I download the file and do something and so on, and then I open the message box. Something like that. So that is the WinProc. That is what.
Wait, is this a truth? Because Thindel says everything that happens goes into WinProc. So
everything that happens goes into WinProc. Yes.
Like to this day, like this is a current.
Yeah. It's I think it's very maybe not VPF, but I'm pretty sure in VPF as well. It kind of leaks through, but in Windows Forms, sometimes you have to call something called application do events. You might never seen it, but what happens is the GUI gets stuck when you're doing operations. And why it's stuck? It doesn't update. That's because no one is processing these Windows messages. So what people do then sometimes is that they call this application do events, which then loops a little bit on these Windows messages and make sure it processes the mouse move and these kind of things. But it's kind of the same as when you doing await these days. Await, and then you let something in. I don't know if that makes sense.
No, it totally does. I have so many questions. So does this WinProc business is really when it's desktop-y, right? Because
this is desktop software, you would say, yes. Okay. Not the browser, but yes.
Okay. And I know you had me install a C++ workload, is that what we call it, for Visual Studio.
Mm-hmm.
And I have some questions around, like, because I've done C# with Layla before, and we made a console app, and we even got to talk to the file system, which is something that I love doing, like getting to move files and save them, and so it's so much
delete
fun.
Them. The best
delete them. Delete all of them. Let's not do that one.
Actually, delete it all. Yeah.
So, but then you were talking about doing a console app with C++. So, what is the difference? And do you know which one Maui uses?
Which one Maui? What do you mean by Maui uses?
Well, my friend was telling me how to use Maui and WebView to wrap an Angular app so you can ship it to different platforms. And so I'm like, oh, Maui is like a multi-platform thingamabob. And I'm like, well, if you can make desktop apps though with C# and C++, that means that Maui needs to be using one of those in order to ship to the desktop.
But from the operating system, right? A C# application and a C++ application looks kind of the same, right? So both the C# application, I'm just guessing here. I have not read this, but I'm just guessing what is happening. So my limits of knowledge, like hitting it, but I'm faking it. I'm pretending.
I love it. Keep faking it.
So this WinProc method is in the C++ application to be the processor, but it's also in a C# Windows Forms application, and it is in VPF application, and it is in Maui application. But what probably happens is if you write Maui, which is a multi-platform thing, is that they have an adapter for the operating system saying this is the way events about the mouse cursor and these kind of things enters into the system. And in Windows, it's WinProc. And in Mac OS, it's something else. I don't know Mac OS. And in Linux, it's something else. And then you have something in the top that sort of accepts all these events and sort of translates it to something that you can reuse all over the place. That's my guessing. At least that's how I would try to build it if I built it.
Is C++ mainly used for game dev? Is that a thing? No.
And embedded development.
Yeah, so where I used to work, when I worked in telecoms, we had a C++ team that worked on the hardware, so like the switches. So my friend Faye was a C++ developer, and she worked on programming the switch, and that handles the call routing. So all the voice over IP comes through, and it's actual physical hardware. So she would program that, super high volume. And then the only time I've worked with it was we had C++ APIs that us on the C# team, we did the website, had to hook into it. So yeah, they all worked in C++.
Okay.
On the hardware. So, but what I was going to ask you, Martin, what you're talking about with the WinProc, how does that relate to machine code? Is machine code even lower?
Yeah, you could say that. That's interesting you say it. So maybe we should start with this console application so we can start talking about these traumatizing subjects for some.
You're cracking me up. You're cracking me up. All right.
So we have this program. So this is a C++ program. And the reason we see that is it's include IOStream, which is too complicated for us. So I would suggest that we change this a little bit here. But if you run it, if you can run it and show people, it just brings hello world. You see here. Now
it's the things that Layla was saying.
Yeah, kind of like what she's saying. So you can compile either to 64 bits Intel or x86.
I'm trying to figure out how to make this size bigger.
We can actually, we should take a look at that.
How do we make it bigger?
There's if you go to the bottom left, kind of above the output label, there is a 100% sign.
Woo! You found it.
Yes, I'm a pro user.
Thank you, love. Okay, so hey, you copied what I wrote. Looking at chat. Let me do.
I think what I would suggest that if you're gonna, this is actually an illegal program, by the way. I'm not sure it's illegal, but it's not. It's kind of confusing. But here's another thing I want to mention to Alyssa, because I think I remember a comment from you saying, "Where does int main come from?" In C#. You see int main here as well, and that is kind of the entry point for that. Kind of not really true, but there's something called that's the entry point for the process. That is what the operating system calls when it wants to start here. But in C#, when you get called int main, the C# runtime has already been started already, and a lot of threads are running. But in C++, you it gets started. You want to hide that?
I'm trying to put it over here.
Yeah, but I can show you a tip. So if you put it there and you take it, so if you take and drag it, and you see, and to the right.
Oh, there's
right?
these things? Oh my
yes,
wordy-gurdy.
To the right. Okay.
Did I do it?
Yeah, it's probably good. And then you see the little thing to the right there.
The pin?
Yes, click it.
Yeah, and these icons are so confusing. Because in my mind, the thumbtack would...
Then you do the on the right side. So we hide that too. Oh.
Yeah, because in my mind, the thumbtack would make it stay there forever. But no, that's how you hide it. I don't...
Well, no, you're unpinning it.
I'm unpinning it. So I'm unthumbtacking it?
Yes.
Okay.
Yes, but I mean, this is what people are saying. This small disk icon up there, the icon, what is this, fifth from the left on top there, does that make a lot of sense to people that never hold a disk in their hand? Save all.
Oh, yeah, that's so true. I didn't even think about that. For people who've never held one.
Yeah.
Oh.
I remember that was latest technology. Cool. I want to make some small changes to this program to make it a little bit easier to debug.
Okay.
So if you double click IO stream there.
IO stream. I did it and nothing happened.
And then you type std. And this is just to make the selection.
Gotcha.
And then you type stdlib.h. Okay, yeah, a good start. stdlib.h. Now we're going back to C. Let's ignore C++. Too hard. And then you see std cout no longer works. So we're going to fix that.
Okay.
And so you remove the entire line.
Okay. Boop. I did it. I removed it.
Yes, and then you type print f. So print and to put them together.
Like this?
Yes.
Do I pass it like
No,
a
no, no,
parameter?
No parentheses.
Oh,
Going
you want
too
it
fast.
like one word?
I didn't say parentheses. Now you type parentheses.
Martin, I just need to tell you something about Alyssa.
What?
She goes.
No need. I watched the streams.
You watch it, okay? You just need to tell her, stop, and wait.
I thought that was a Lila problem. So
It's not
but I'm
me.
learning so quickly.
It's her up there.
Anyway,
I
so now
did
you can now you can type hello world inside string quotations.
Does it matter which strings?
Yes. This
Right.
is C++. It matters. It matters.
Wait, it matters in C. Doesn't it matter in both C's? No.
Yeah.
Yes? No?
But not in JavaScript. Hello world.
Right. How do we?
And then after this, you type return 0.
Ooh, like on a new line.
Yes. This means everything is good.
And there,
I think I said the wrong thing. It should probably be standard IO instead of standard lib. I said the wrong thing. I'm not perfect. I will admit.
Is it happy?
Yeah, and now you can run it.
Oh, it is happy.
Yes.
So what is standard io.h mean?
Yeah, this is old stuffy. This is 70s, old C. So this is how you printed things in the 70s.
Did it print?
Yeah.
There it is.
Yeah, but we don't see it on screen.
You don't? Oh, because I'm sharing the wrong thing.
We don't?
Let me stop sharing, and then I'm just going to share everything, share screen, and that way you can see when things pop up. And
hello world, amazing, right? Now, what I thought we could do is, what does that translate into in machine code?
Ooh,
Yeah.
like ones and zeros?
Not really, but this is kind of how low we can get in C++ in user mode. So close this window, and then you make a breakpoint here.
Like on 8.
Yeah, yes, on the number 8. And then you hit F5 to debug it, or you click the debug. I don't know how you want to do it. I want to debug it.
I know I like that you remind me about F5. I have to like.
And now you click the source code.
The source code.
Yeah, behind. And then you click. This is a shortcut for this. This works for me. Control-Alt-D.
Control. Wait. Alt. Yeah.
Yeah.
D.
Right. There's a shortcut for going into assembly mode.
Ooh.
So this is what this program translates into.
Wait. What?
So these are the instructions that are happening here. So when we are typing code like printf and these kind of things, it is translated into a low-level language, which is called x86, x64 in this case. And it's a little bit hard to digest here, but what you might see here is there is something called Lea, and at the line you see the breakpoint is RC6, and what that line means is, now I'm going to use words that you might not be so familiar with, so we can just stop and talk about it, but it loads the address of the string into a register that is called RCX. And if you hit F10 to hit a line.
But did it do it? I think it did it.
Yeah, and now there's an instruction to the CPU that says call, and then it will jump to this and print out this function, this string, and then you hit F10.
Wait, where's my breakpoint? There you are, darling. F10. Oh, to walk through again.
Yeah, then you probably. Oh, it's lost. Now it's good, and now it printed it. So that's kind of it. So shall we unpack what I said a little bit there, because I'm not sure you were entirely with me there.
No, so I was reading chat and they were saying, like Thindel was saying, this is literally what the CPU does.
Yeah, I don't want to. The CPU is actually kind of high level, because so in some sense, its CPU is very low level, right? But it's also very high level, because what really happens when you so if you look at the line, it's hard to see here, but you see the first line is called push RBP, the first line at the top.
Yep.
What that thing does is that it takes a register, which is a variable, which is an integer, and stores it into memory. But if you think about what really happens when that happens, it's kind of incredible, in my opinion, because the CPU reads and decodes these bits and deduces that this is supposed to do something. Then it checks, is the memory in L1 cache? Is it an L2 cache? Is it an L3 cache? And these are like different kind of units inside the CPU that communicates often through kind of some kind of message-based system. And then it doesn't find it, perhaps, or whatever. Now we're pushing it, but it doesn't matter. And then it go out on the memory bus and starts communicating and trying to figure out, using the memory controller, where is the actual memory located on your chipset. And then it starts talking to that over electrical wire. And that sort of chipset then starts sort of, I'm going to search for this memory here, and then send it back over the wire, which is then coming back, stored in L1 cache, and presented to you.
Are people writing this?
This is high. No? This is high level.
Are people writing this or no?
This kind of code?
Yeah.
I think quite seldomly, but you do it for certain kind of like if you look at for example if you .NET code, they have certain code for handling when it comes to garbage collection, which is kind of a low level thing. They do sort of memory barriers and these kind of things. And that is actually written, from what I can tell, in assembly when I looked at it last time, but maybe I'm wrong. But it is for really specific purposes, when you want to have very minutiae control over what happens.
Okay.
But the problem is, of course, that when then someone says this has to work on ARM Mac OS, right? Then this code doesn't work, because this code only works for a CPU that supports x64.
Okay, hang on. CPU that supports x64.
Which is an Intel CPU.
Do you think there are things like TVs or tablets out there that use that?
If you take, there are probably a few TVs and tablets out there, and the Ericsson base stations uses x64 as well, because it was cheaper. So they use PowerPC. When I was at Ericsson, just to give you an example, when at Ericsson, I used PowerPC, I used ARM, and I used x64, because the architectures that I was working on uses different CPUs, and one of my specialities became debugging low level on all these CPUs. So yeah, that was kind of fun.
Wait, so what does Mac use? If not
ARM, quite a much more advanced version of ARM than what I was using, and it was a pain to debug. So yeah.
Wait, but this will run on? No, this will also not work.
This what you compile here only runs on Windows, on a machine that has support for x64. So this is not. So C++ sometimes is said is a sort of multi-platform, right? But not the binary, not what you produce, not what the compiler puts out. That's not multi-platform. What you can do is taking this program and compile it on the ARM, on the Mac M1 ARM, Or
Is
you
it
can
like
take it and
is it like a transpiler? So it like changes it?
this is a compiler, but maybe you can think of it as transpiler. But because the C++ compiler is implemented on almost every platform there is. So you can take this code here and compile it on the Mac, on your Raspberry Pi, on anything, on our base stations at Ericsson, and it will do what it says on the screen. But you can't take the compiled result and transfer it.
Okay.
If that makes sense.
Is this all like whenever I hit play and I'm running this and we get the little pop-up, is this all there is to this application, or are there other files?
Yeah, kind of. That's a good question, I think. So one thing we can see here, which is hard to see in, so maybe I'm not sure I'm answering the right question here, but it's kind of is all, because one of the differences between C++ and .NET is here we can see the very first point when operating system called our process. In .NET, we only see it when we are inside .NET, but a lot of things has already happened. So you can see the call stack there if you go down right.
Down, you're talking about on the disassembly one? Or
Yeah, no, if you go a little bit down right.
I'm confused.
No. In sort of in these Windows things here, you see there's a below the source code.
Below the source code. You're talking about these call stack bits?
Yeah, that's call stack bit. Yeah, it says external code here. But you can actually, and the external code is Microsoft saying you are not interested in that. But of course you are interested in that. So we're going to look at that code.
Do I double click it or?
No, you can't, because Microsoft is saying you probably don't care. So, but what we can do,
symbols. Would that be?
it's kind of like that. So we need to disable.
That is
something.
super frustrating. There should
Yes,
not
it
be
is.
any
Show me
files
everything.
I can't touch. That's ridiculous.
Yeah, stupid. I agree. So if you go under Tools menu.
Wait, there's a Show External Code button. Or I mean,
Yeah, you can try that. Maybe that works. This is not what I prepared, but it doesn't matter. You
Hang
can
on.
try
Did it work?
Show External Code.
Let me see if I can make this
Yeah,
bigger.
I need to.
Super
It's
small.
very small. This screen here. Yeah,
You have
know.
to go into environment to change that.
Yeah,
to
but
make
this
it
looks
bigger.
good.
File.
So if you click the bottom line there in the call stack.
This one?
The DLL one.
Yeah,
Diddle.
you have to switch to assembly mode as well.
I'm gonna
You remember the
switch
keyboard
to
shortcut?
assembly mode.
Yeah, so try clicking that again. That time.
And then I'm gonna look for environment. To
Yeah,
make it bigger
yeah,
for
you're right. So here
chat.
is kind of where the operating system comes in. And we're still inside operating system, but here is kind of the first time. As you might know, the operating system have two modes, sometimes more, but it has a mode called kernel mode and user mode. And here's kind of where our user mode code starts executing. In kernel mode, scary things happens, which I don't know anything about. But in user mode, now the operating system calls into us, and then it starts calling by calling ntdll, which is something that the operating system provides for us, and it does things. But this is kind of the initial point. There's nothing before this. And there's no threads created. And then what happens is, it's called, if you click the line third from the bottom.
Third from the bottom.
Yes.
Press the play button.
No. If you go to call stack button, call stack window.
Bottom
call
right,
stack,
that's
this
it.
one.
Yes.
That
Here.
one. Gorgeous.
Here, you see, go up there. There's something called main Crt Startup. That is the startup before, that is the first time a C++ or any code can execute. This is what the operating system calls. Okay, I've done what I need to do to sort of prepare this process. Now, here you go. And this happens in .NET as well. .NET has this main Crt Startup also. But then they do a lot of stuff. Here, what happens is they start the C runtime, which is a little bit, but nothing compared to what .NET is. But here is kind of the entry point, the first possible entry point where you, Alyssa and Laila, can hook in your code and do magic.
Are you saying like I can just be like copy and then go over here and then I can
Yeah,
be
you
like,
could probably do it.
this,
It would be, you could actually copy and create. Yes, kind of. Yeah, you can't call it, but you can kind of do what you're thinking, right? But you would run into problems because there is no printf, nothing is working, nothing, because it does things. But yes, you can. And this is actually what some people that are crazy do.
Why? Why are they crazy?
Is that you, Martin?
Sorry? I've been dabbling into this, but I can't be bothered.
I just spit on my screen.
there is, we talked a little bit about shaders before starting the show. So there is a community that enjoys building executables that are that cannot be more than 4096 bytes. And that in 496 bytes, they put in impressive graphics, impressive music, and a little bit of design as well. The only way to do it really is to remove everything of this garbage that the compiler puts in and only put in your code to do everything and do it as small as possible.
So we would like write in this file.
Kind of, right. And you remove and you turn off all C. C is bloated, too much, right? So that's how you get down to 4096 bytes. And there's even people that go down to 1000 bytes, but they are probably criminally insane and should be avoided.
Have you made one? Have you competed? Can you compete?
I've been trying to make some. I think I can make the shaders, but I can't make the music.
What is a shader?
The shaders are amazing.
Can someone describe shader, please? Define it.
It's like a program.
Fractal art crap.
I don't know if you watched my Twitter, but I posted a few images.
Let me go pull it up. I'm going to pull it up right now.
That are shader images.
I'm gonna pull it up and make it bigger, bigger.
I'm promoting my Twitter channel here. Yes,
Martin. Ugh, the searching and the slow bits. This guy?
Yes. So if it's called, that's a shader image. That is generated purely by code. This is a Voronoi pattern.
Hang on. I want to see the code. I want to make the code bigger.
And this is just a picture. You cannot see it, but I think you have an even prettier one down below here. Yeah, that's pretty good. Yeah.
Hang on. I'm reading this. Vec2 UV. What is this code?
This is kind of C code. But
this is C code? Okay. You can't just be throwing a third C at me.
Yeah, this is a third kind of C. And I just want to point out, in this program here, there is no pictures. Everything is generated by math. So this,
I mean, like for someone used to like inline SVGs,
yeah,
that makes sense. Like it's totally legit.
Yeah. Could be that. It's different, but
is it? How is it different?
Well, you don't draw lines in that sense. You use more classical mathematical functions, right, to do so. But it is it is a kind of a very mathematical. So I think many people see it think, he probably has a texture and sort of this kind of thing. There's nothing like that. There's no triangles here. Everything is just mathematically generated.
Where do you use shaders?
Where I use them? In games a lot. I use them just because I like to do them.
I'm going to throw this so people can
scroll down. I think I'm very happy with my tree. I want to show that one.
Ooh, there's a tree. A tree. Oh, it's so pretty.
By the way, this is of course all moving. So all the leaves are falling off and things like that. This static is
that is gorgeous.
It's also real time, of course. Nothing in videos. That's boring. So that's what I enjoy doing.
How long is the code? Like
it's not too much, I think, but maybe 200-300 lines. I could squeeze it down.
That's really cool.
You've been writing it a bit bloated, is what you're saying, yeah?
Yeah, I write bloated code. Yes.
Oh, that is cool. So for like the animation of, the pieces falling off the tree, is that dynamic or is there actually a line for every single piece?
So in this particular case,
surely not, because there's more than 200 pieces, so it'd have to be dynamic.
I don't draw each line. I use a lot of randomness and to sort of generate, and a lot of smooth it out. But essentially, each leaf, without going into too much details, has a position on the tree, and then I wait for a while, a random interval, and then I let the tree, then I let the leaf start blowing with the wind kind of. So I just adds to the position at the same time letting it fall to the bottom and a little bit of wiggle. This is just sinus and cosinus.
That's like such an interesting thing to get into. Like,
yes.
Was it because of gaming that you got into shaders, or was it just?
I was bored by every other programming. This whole program is boring.
Of course.
But also this comes back to so a little bit to my history, which nobody might care about. But blindfolded, yes, of course, that's the way to do it. So when I started, what really got me into programming, quite a few years ago, was something called demos. And when I had my old Atari, people, what they did was kids, they put down code that did graphics and music together and moved cool. And I wanted to do that. But I never really succeeded. And I think I had this kind of sense of, I'm not sure failure is the right word, but sort of, I want to do that. So now I do these things. So I have actually put together a few demos. Not sort of,
Are you talking about like mid-90s? You can find them on YouTube. The demos, they're all computer graphics. They're all screaming through that, and the music. Yeah, Jim makes me watch those. They're very cool.
Oh wait, like still currently today?
He'll make me watch them,
what I can tell you, which is even more amazing and might bore you even more, but is that the old Atari kind of died in 1993. I stopped using it then. It was died. So there was no point continuing it. But now, 2020, I learned that the Atari demo scene is very active. And there's a lot of people inside it and are producing a lot of cool stuff that are kind of mind-blowing. Because I know a little bit about the hardware limitations. Because if you look at the GPU, now coming to a little bit something else here, but the GPU has exploded in performance. On my old graphics card, I think I have 10 million times more performance than I had on my old Atari. Probably more.
Wait, so can you still buy
Ataris? If you search for something called cuddly demos.
Did you say cuddly?
Cuddly, Cuddle.
Cuddly, whoopsie. Why?
You're streaming, that's why.
So, are these?
Crash Google. Oh well. Yeah, this thing. When I first saw this thing, these things here, right? These screens, but they're moving. That blew my mind. I was like, because I was thinking, yeah, I should learn BASIC. But then I realized I can't do this in BASIC. BASIC sucks. I need to learn machine code. And this is what really got me hooked on machine code.
So can you still buy an Atari if you wanted to start writing these?
Very expensive.
I was gonna say, or like, I mean, they're not making them still, right?
So no.
Okay.
No, they are long gone.
Okay. That's what
you see, this is hot. This is so cool stuff. I was like, oh my God, I'm gonna make this in BASIC. Throw BASIC out.
Is that how? So how they are using BASIC? Yeah, to write.
No. They use assembly code.
Assembly code.
And they're using a lot of tricks, which I know.
I don't know how to do them. That is so cool.
Yeah.
Did you see the question? I think I highlighted it, but I don't know if it's still highlighted for you. 1 second, let me find it. Martin, did you ever go to old school DreamHack?
No, not DreamHack, but I went to things before DreamHack. I was kind of DreamHack didn't really was a thing when I was going to things. So I went to metropoles like Skövde in Sweden. Tindal knows what that is. It's a really cool place. And slept on bare. When you was young, you took your computer, carried it was quite heavy, and went to a big room with a lot of nerdy guys. If I'm being honest. And you played computer games and swapped discs and sort of, oh, this guy made something really cool. And then sometimes there was a rumor in the hall. Omega has entered the room. Omega was a demo group, and they were, they're gods, and they were complete jerks, if I'm being honest, because they were 18 years old and they were high on their fame in this very limited group of people. So they were acting like rock stars and trashing things, and and if you imagine, I mean, there were maybe 100 people in Sweden that knew who they were, but to those 100 people, they were bigger than Beatles and everyone.
That is funny. Someone was saying LAN parties. These sound different than LAN parties. They sound like LAN party conference type things.
I don't know.
Yeah.
and that was also one of the few places when you had a chance to play network games, right? Because internet didn't really exist. So then you brought your computer and you hooked it up using special cables to other kids' computer, and you played these network games, and you knew when I'm going home here, I can't play this anymore. So I'm going to stay up all night and play network games. And I'm going to sleep on the train home.
What's the so I'm sure that Jim or Silicon Orchid told me about like you could record something on the radio overnight or something. Was that something? Am I imagining that you could program your video game? I know there's the ones that you used to get them in the back of a magazine. He's told me about that. But there was one, it might have been from longer ago and he didn't do it, but where you record something on a cassette off the radio and then that was kind of the game. Is that something? Am I talking utter
I'm not exactly
rubbish?
sure what that was, but it
That
reminds
sounds
me
fun though. We need to like look into that, Layla.
when you swapped software on cassette discs, right? You had a friend that has a double decker. That was a very important friend in your neighborhood, because then you could get this cool game on this cassette player and you ran over to his play and you copied it, you know.
Alyssa, do you know what a double decker is?
No, but
God.
What does it sound like?
It's not, it's a big ghetto blaster with 2 cassette decks.
Yeah. And what the big feature
I'm
was
going to find you a picture.
No, but it's a cassette drive. So what does it sound like when you play it?
It has speakers. So they
What,
have
you mean the
it's
cassette?
music.
Yeah.
The game.
Well, like it's like one of those old cassettes that you like listen to music on.
Yeah.
And you're saying you put data on there. So what does it sound like when you play the audio?
Yeah, that sounds like a modem, if you know what that sounds like.
Does it? Yeah.
And of course, what happens if you didn't have that cool equipment was that you put through and you tried. Of course, you were desperate, and I mean, you wanted to sort of. So you what you did was you had a cassette player with speaker on, and then you had another cassette player and recorded it, and you pressed and you left the room in the hope that would work. But then you found out that your bird has been singing along to these tunes, and so it's kind of overloaded. So you know, it was.
Carb. Thank you, Carb. That is exactly what I needed. Like that's what it sounds like when you play it.
I have certain songs in my head remembered as with bird chirping. I mean, when I'm hearing the real version, I'm like, where are the birds? You know, because that's what I remember.
You know what this reminds me of is the first time I learned about data being hidden inside of images. I don't know what it's called. It has
watermarking,
subliminal messaging.
No, I mean like you can actually like hide like Alyssa Nicoll like in like the pixels or something and like read it, and so it reminds me of that because it's like data hidden in sound. It's sound driven data. What it?
Yeah, I mean it's you overload the data with something else, right? And sort of you hide it in plain sight. So that's
so cool.
I think that's probably very possible to do. Do you want to make another little stab at the programming thing here? Because I wanted to show you something.
Let's do it.
I might have to go because
thanks for joining us, Layla.
Yeah, seriously sulky brats here going like, where's my dinner?
Yes.
So I'll try and carry on watching on my phone, but I'm going to drop out. Thank you so much for letting me crash and say weird things. And thank you so much for showing us, Martin, the stuff you've shown and blowing my mind. My mind is hurting. So I will, I'm going to carry on and watch on the phone and I will catch you all later. So cheerio.
Bye. I think Guac is right. I think it was steganography.
Might be. I don't know what that is.
I think that's for the first time I heard that, I was like, you can do this. So this is kind of like what you're saying with the audio. Let me share screen so we can look at. So the last thing that I was trying to do was
so what I will suggest that we try to do, just for the fun of it, is that we make a function and we call that function and we print the result of the function, and then we can inspect the machine code and we can see what actually happens when you call a function.
Did I make a function?
Yes. Call testing, yes, but C++ is a little bit special in that you have to declare it before your usage. So I would move this above the main method.
Oh, okay, I can do that.
It's like F# in that sense.
Oh, I still don't really understand functional. I just like the idea of it. I need to. Okay, so
I suggest we're going to make it very simple. So I'm just going to suggest that you take 2 int parameters in. So you type int a, comma int b in the inside input parameters.
you're talking about in the testing parameters.
Yes. Yes.
What is with int?
It's simple.
No, but what is it? I don't get it. It's like var.
Ah, okay. That's a good question. Yeah, let's look at that. So, and then I will suggest that we're just gonna take the sum of this and return it. We're gonna write some very simple code here. You need to write a comma.
It's yelling at me. Maybe why is it not yelling anymore? Okay, you all saw that. I'm not crazy.
But you had a semicolon, I think. I don't know. And then you type return a plus b. It's almost like a JavaScript.
Okay.
Inside. And then inside your main method, you make, for example, int x equals testing 2,3. I'm just no, not here. Inside the main method, or maybe you're doing it, but it's a little bit laggy.
No, you're totally right. I wasn't. Int x equals. What do you say? Int x. We're
equals testing.
And then you wouldn't pass it.
2,3.
And then.
Yes, and then a semicolon at the end. Very picky about that. And then we're going to print it. And the way we print it is we use this printf. And here we're coming back to a little bit what you did in F# when printing, is that you have to use this percentage D to print it out. So the F# printf command have kind of a legacy that goes back to C in that sense. So, but you have to put it inside citation marks.
Quotes?
Yeah, quotes. Yeah.
These? Like that? Like this?
Yes.
But where's my X?
Yes, I'm going to show. And then you type slash, no, not there, slash n, and backslash n to make a new line.
Wait, and new line that?
That's,
is this all supposed to be one string?
Yeah, one string, but that's not a backslash, that's a forward slash. Or I have it confused, the other direction.
I honestly am like super dyslexic when it comes to the slashes.
It's
so
fine.
Okay, so slash in, so
and then
for
you
new
type
line.
comma after the string.
Oh, okay, outside. And then we put our variable?
Yes.
Is it happy?
Amazing. One of the best programs I think we ever written.
What is the %d again?
It means take the input here, the x, and present it as an integer. If you type something else, if you type %s, it will say, oh, what you're sending in is probably a string, and then it just crash. Here is why a little bit why C++ and C is a little bit difficult, because if you mess things up, it probably crashes extremely hard. We can try that too, but shall we just see that this thing works? That last thing didn't work.
Now it's angry. Wait, why are you angry?
It doesn't like that. You remove it.
So grumpy. Okay, but I just want to see, and it's all like grumping at me.
No. Here's
5.
Amazing.
Wait,
so,
okay, so.
And here's another suggestion, which is might be confusing, but we're going to switch to release mode, because when we do it in debug mode, the compiler puts a lot of junk in the code that makes it hard for us to understand what's going on. So you switch to debug mode, release mode. You see it says debug x64.
Oh, is it next to this?
You see the x64 you clicked before.
Oh,
right?
over here.
And then you go left of that. Click release.
Release and
then you put the breakpoint on the printf. And then we're going to debug.
It's like still circling on me. Are we worried about that? Did we just break it? Okay.
Probably. But put the breakpoint on the line 14.
And then we press play. Ha ha ha.
What's the worst can happen?
My computer explodes. I think that's the worst.
Universe ends.
The universe. You're right. Wait, is that the worst? I don't think that's the worst because
we get out cheaply then.
Exactly. Well,
I mean, if it turns out that the whole reality is a thin veil over a brutal hellscape, and it turns out that we basically enter some of the Hellraiser universe, that's worse.
There we go. We've topped it.
Yeah.
I don't understand. It's like angry at me. I'm not getting.
No, it's fine. It's brilliant. You see, it's breaking and stopping there. But now you have to click the magic super secret keyboard shortcut to switch to the assembly mode. So if you click the source code,
this one, X.
Yeah. Now what happened here is quite interesting. We see what it does here. So let me see. I think we have. I'm going to check my screen. But if you see you see down there, yeah, it's hard to explain.
Are you talking about in the output? In the autos?
I'm going to search for something here.
See, autos.
Yeah, the autos. Yeah, right. Right.
One?
What happens if you type EDX there? Does it work?
If I type.
Yeah, you see, there's EDX. So when you run this line, when you run F10 now and run this line here, now you see your register becomes 5, which is the sum.
What's with these different formats?
Yeah, that's just junk. You don't have to care about that.
I did not think you, sir, would ever tell me that.
Yeah. So, I will say sorry. Okay, but okay. Let me tell you really, I don't know why it is there. That's my honest answer.
Okay.
But now, when you hit that line.
So EDX, that's 5.
Yeah.
And EDX is what again? It's just.
It's a special kind of variable called a register, which can hold an integer.
Register. Okay, hang on. I gotta write this down. Register. Register variable.
You know, it's already pointing out a few things here already, but so this is something I want to show as well. So we don't see a function call here. We just see that the compiler has just computed the answer for us and give us 5 because it realized, well, when you call this function, the result is always going to be 5. Why am I going to waste time on computing something that is always true, to be always the same? So we have to trick the compiler into actually perform the work for us. So shall we try to do that?
Yeah.
Yeah. So if you stop this program,
I will stop it.
So this is a problem with C++. It's too smart. So if you extract 2 and 3 into variables, let's call them A and B.
Inside of main or outside?
Inside main.
Int I is equal to 2.
Call it 2. Perfect.
Wait, shouldn't we do something more convoluted like?
No.
Int 32.
You can, well, you can, but I'm not sure we need to. But
okay.
I don't want to stop you if you want to do it, but as you
I just thought maybe there was another type that I should probably.
Yeah, there are many types, but there's a lot. And
can int be anything?
Oh yeah, that was you had a question before. That's a very good question. We should try to remember it. But I want to show you this thing here. Right? Now, if you run this program, we will notice that nothing. It does the same thing because it's just too smart, the compiler. So if you switch to assembly mode, you see we move number 5 into the register EDX.
Number 5 register EDX.
So we did
this one like that.
Yes. So when you run it, it will become 5. So it was just too smart. But here's a trick that you can do. So if you stop this thing here.
I was reading Carb's comment that said, on a regular machine, int is the same as int 32.
Well,
what's a regular machine?
Well, sometimes if you have you can imagine if you run, I think int kind of loosely means the integer type that is most natural for the machine. So what does that mean? So my old Atari was a 16-bit computer. So on that computer, int would probably be a 16-bit. Now, does that make sense when you say 16 and 32 bits? Well,
yes.
Does that mean something? Yes. Great. So, but on the X on the X86, which was a 32-bit, at least 32-bit processor, int then became 32-bit.
Yeah.
But on X64, you could argue that int would then naturally be a 64-bit number, but that would break too much code. So they have gone away from that thing. So now you actually have more specific types.
This is the weird thing, though. We're using int also for functions.
Yeah, but in C#, int is always 32-bit. It's never is. In C++, it's very vague. And that's why newer C++ actually have these specific data types. My avatar was 16-bit, was high-tech. But what
I saw that, Aztec.
What I wanted to do is you put a volatile in front of int. You type volatile.
Wait, I can do that? Hang on.
Yes.
Volatile.
No, not there. Sorry. Int 8. Yeah.
Volatile.
And this tells the compiler.
Volatile? What the?
Volatile.
Quit that.
Volatile.
It's like pop-up central.
You are so volatile.
Did it do it? Is it happy?
It's super happy. And then you do it for B as well.
Okay.
So this tells the compiler that, you can't really trust that these are 2 and 3. So when we debug it now, we will probably see that it's trying to do the computation.
Whoa.
Yeah. So,
Whoa.
Yes. So, if you look at the lines just before here, it says move ECX dword PTRB. It's a little bit, but what it means is you have the B variable in the memory, and it says put the B variable into the register ECX, which is just a name for a variable kind of, and then load the A variable into register called EDX. And then it says add them both together and store the result in EDX. That's the add thing there. But I think if we stop here and we put the breakpoint slightly different, we can actually step through it and see what happens.
Where should I put it?
Put it on the volatile int B.
I'm
sorry if I'm ignoring the chat, by the way.
Oh, they are saying a lot of words I don't understand.
All the Windows stuff here. Well, at least with the Microsoft naming in that thing, it looks like a Windows API and not like a fake C API, where Unix standard functions often look exactly like the C standard function. So you can have a hard time telling the difference, what is standard C and what is Unix. Anyway, it doesn't matter. So let's step F10, if that's okay.
Mm-hmm. We got a 1 in the ECX.
Yes. And now if you take the ECX there and you hit it, then ECX became, what does it say? 2, 1? I don't see on the screen.
It says 3. Well, I hit it twice, though. Is that bad?
That's good. And now so B was equals to 3. So now ECX is equal to that. And now we're going to hit the next line.
No, so EDX right now is 2. Because
we loaded A into EDX.
Right, which A is 2. And these are just registers, which mean pinpoints in my computer that I can save things to.
So I don't know exactly what the register is, but the way I thought about it before is the register is the CPU cannot really do cannot do operations on things in memory. It has to load it inside something called arithmetic logical unit, but it has a special variable that it can do operations on, a special place, and that is called a register.
Is there a limit?
Yes, there are like 8.
Really? There's only 8?
Yeah. On ARM, there are like many more. So that's
my gosh! Yeah. I gotta go see them.
But it's very. This is basic. There is also something called AVX, and that's like 32 of them. So
I want to see them all. Hang on, A, B,
yeah.
C.
I'm not sure that's. Well, you can try that. Yeah,
it's not going to do it.
This is a good idea. I like
think
it.
it's going to save it to something else. A, B,
Yeah,
C,
but I think
D,
we're going
E,
to see something happen. Yeah.
F. 1, 2, 3, 4, 5, 6. That's not
And
enough.
what you do then, I think you just can write int x equals a plus b plus something.
A, B, C, D, E, F, G, H. Do I actually have to use them for it to save it to the register?
I think we should use them to see what happens. So,
okay.
So instead of doing int x equals testing, now we're going off script, but that's fine. Then you type a plus b plus c plus d plus e plus, the whole thing.
Do I type it within like a console or just do it?
Yeah, no, you do it here. Int x equals.
Oh, I see what you're saying. Remove the index part. All right, hang on. Let me do this. That didn't comment it out. Oh, I forgot how to comment.
It's forward slash.
/ this one?
Well, we'll see if you get the pointers. That's backslash.
A plus.
Great.
Okay, so int x is equal to, and then we're going to add all these together.
Now, I don't know what's going to happen here. I have a guess, but I'm not sure.
G, H, and then that. Wow! Did you see that? It added all the spaces for me. It was so
amazing.
Fancy. Oh, I got rid of my debugger. Is that needed? I think it's needed. Let's go put it back.
So put the breakpoint at, that's good. That's good. And now we switch to the super awesome Control Alt D. So
wait. AEX is new. Yeah.
Okay, you see here, right? It's angry now because
AEX. Wait.
So
what's angry?
Okay, you can. Do you want to try what it does?
We only see 3 registers.
Yes, because you have too many here.
What do you mean I have too many? I don't have
too many. It's too many for a register. You cannot load it all into memory. So what it does here, it loads H into ECX and loads G into EAX, and then it adds EAX and ECX together and store it in ECX. And
I was worried about this. I thought it was going to try to do something funny so that we wouldn't get to see all 8 register names, and it is, right?
But there is a special window, but I'm not sure what the name is, so we can actually see the registers. I'm just going to.
There's a special window. Are you sharing your screen?
No, I don't. My machine is not so cool as yours, so I cannot stream and program at the same time. But I'm gonna.
I'm disappointed that I did not get to. I wanted to see all the register names.
Yeah, but I think we can.
You think we can see them?
Yeah. Maybe someone in the chat knows.
Yeah, let me.
They
were saying that there's not that many registers. And Carbon was asking, you mean available or on my screen? Thindle said available. There's more than 2. Yeah, I feel like I'm with Carb on this one. I'm voting for 8, and I want to see all 8. I think there's got to be more than 3.
Yeah, there are more than that. I tried to search for. So there are maybe.
I wonder if
maybe if you click locals there, it says autos. If you click locals,
it says autos.
Down there's a tab on the bottom.
Oh, what am I saying?
No, that's not the right one, right?
What the heck? Variables optimized away and not available.
Yeah.
Funny.
I'm pretty sure it is, but I haven't in my head, so to say, where it is currently. I'm sorry about that. I don't know everything.
Bindle said, tell a JavaScript developer that 16 variables is a lot. Well, I get that we can't have infinite because hardware is not capable of infinite, and so I thought it would do this smart business where
it is actually quite clever because what the compiler realizes is it can destructively add it, so it doesn't need to load everything in different registers. It can just.
Do you think that would ever mess something up? Like if it's trying to be smart about how it's storing math?
Like, well, actually, that's also
if it did something out of order or something. Like
that's actually a good point, which is kind of low level. So in C++ compiler, there's something called fast math versus slow math, and what that means is that fast math allows the compiler to reorder your instructions, your math operations, in a sense that would be mathematically correct. But because it's floating points and we have rounding issues, reordering the math might not give the same result.
Yeah.
And that might cause crashes. So these kind of things where you are kind of doing things in the different order might actually cause issues, especially rounding floating points. So with floating points, if you do a plus b plus c, might not be the same as b plus c plus a.
No, yeah, I love that. So you're saying it's called fast math versus what was the other one?
I think it's called fast math. Maybe you can find that option in. It won't make any difference here, but there is an option here under things like that. So.
It's not something you would actually write. I was imagining it was like something where I tell this to be fast. Yeah. You be fast math.
Yeah. So what I wanted to show you before with this testing here, AB, was how the call looked. But we saw what we saw here was that it was very, very smart. So it actually inlined the functions. Have you heard about inlining?
I've heard about it. Could I explain it to you? No.
But that we can, by doing this, you can actually see the difference. What does that mean when someone says inline?
Okay.
So should we try to make it not inline?
Yeah. How do you do that?
Yeah, that's a little trick. Now we have to turn off optimizations a little bit again. But it's not so hard. But you have to type exactly what I say. So you go to the testing function, and then in the front of it, now I'm going to just dictate before the integer. Int.
Oh, before here?
Yeah. You go underscore. DECL SPEC. Parentheses. This is special instructions. And inside the parentheses, you type no inline, one word. Very good.
Did I spell it wrong?
No.
Oh, there it goes.
So what we're telling the compiler here is that, yes, I know we could inline it. It would make it go faster, but don't do it. Let me see what happens. So now when you debug it, the code is going to look a little bit different.
I want to go. Wait, autos name. Wait, what?
Control Alt D, I think.
Oh, am I not in this one? There we go.
You can do this in C# as well. You can actually see the assembly code in C# as well.
So if it's assembly code, why does it say disassembly?
It's hard. It disassembles the machine code into assembly code. I guess. I don't know for sure. It's just it's all these kind of words you just accept after a while. It's assembly. But it probably doesn't make a lot of sense.
Jiva was saying that the one ID I hate is Visual Studio. The one that I love is VS Code.
I will tell you that my Visual Studio code is currently entirely in red mode because they broke my theme. So I'm running the red theme in Visual Studio code because I'm so angry. So I'm not a Visual Studio Code fan right now.
Did anything change?
Doesn't matter. Find the IDE you like and love. It's fine. No, something changed. So you move this into ECX. But now what you do is instead of adding them together, you call the functions. So what happens here is now they are loading the parameters for the functions into the registers. And now it's going to call the function, call, if you step down there, and you hit F11 instead of F10.
Oh. Did it do it? Are we happy?
I'm not sure. I don't see. Did you hit F11?
I did, but maybe I did it improperly.
Good. Now you jumped into the function. So now, great. Now, before you remember, they did the addition inside. We inlined the function, but now instead, it jumped to another place in memory. And here you see it says LIA. I don't know why it switched instructions here, but it says add RCX and RDX. And this is super confusing about the x86 because each register has many names. So the EAX register, I'm sorry I'm telling you this, by the way, if you don't want to hear it.
No, each register has many names, but it's the same register?
And the reason for this is the x86 architecture, x64 architecture has been around in the 70s. So in the beginning, I think they were called AX, CX, and DX, something like that. But they were 8-bit or 16-bit. But then they realized 32-bit is kind of a good thing to have. But we don't want to break old code, so we make the AX register 32-bit. But if you type AX, it's 16-bit. But if you type EAX, it's 32-bit. But if you type RCX, I suppose it's 64-bit, right? So it's all this kind of backwards compatibility, these kind of layers of just adding functionality and never fixing it. So,
I mean, you can't, right?
It's very hard to do. Well, there comes a new CPU sometimes, like the ARM CPU, but the ARM CPU is old these days. It's like 30 years, something like that.
Is there going to be a new one that replaces ARM?
I mean, the hard part about coming out with a new CPU is the Intel CPU, for all its flaws, they have invested so much money into making it reasonably fast. And if you're going to make your new CPU, you have like 30 or 40 years of investment to catch up to. And you're going to be compared in performance against them and sort of saying...
I guess I just assumed it's kind of like how like the Angular team rewrote the Vue engine. Like, I assume it's just, it takes time, yes, but you have all of that 30 years to look back on and make it better, right? Like, it's not like you're ignoring that, right? You utilize it and stand on top of it. So I don't know. I guess it would make it more painful for developers then, though, because then there's a new...
If you take my current job, the Cobalt application has been developed for 40 years. So when we are going to write our new application in C#, we have 40 years of features to catch up to. Now, we make things a little bit different, so we don't have to catch up to 40 years, but it's a mountain of features that people are expecting because it just works in the old application.
I see.
So we're going to catch up to that. And, and the new tools aren't that much faster to develop things in. The old Cobalt IDE was very efficient to develop things in. And was well made. So
why did it go away?
Why did it go away? The Cobalt IDE. Well, people hate Cobalt. They don't want to do it.
But why? Is it not fun to write?
I think for most people that are most critical to Cobalt has never written a line of Cobalt in their life.
That could be. I think that could be said about most things, if we're being real honest.
Right? I think that is true, right? I hate this thing because
I wish there was a way to just like mute everyone with negative opinions if they've never even written a line of it. Like that would be so amazing.
It's called turning off Twitter. So, but joking aside. So, but then of course, if you look at us, where we do so. It's not so clear because it doesn't really matter the syntax. Sometimes and Cobalt has a huge advantage over C when it comes to the kind of applications that Cobalt were made for. It has a decimal data type. It has sane functions for dealing with sort of ERP software, accounting, logistics, these kind of things. It's great at that. It's great at creating forms. It's a very productive environment for people. And the code, for a Cobalt developer, they don't care about that. They care about shipping features and functionality to users. Most of them that I met. That might be the only one that survived, so to say, because they are like 70 plus years old. But it was a quite amazing environment. But one of the key things for us switching is that customers today are expecting a web application. And there is no Cobalt.js yet. So, and we want to change certain things as well, right? So, and you can't find any new developers that want to do Cobalt. Like
Zindel said, I have a language that can't represent 0.33 in a variable, and I like it that way.
It's a very common number. And by the way, there was a guy called Kahan, and now we're going to get way before my time. But one of the designers of the X87, which is the floating point CPU, so in the olden days, you had a CPU that could do everything except floating points, because that's too hard. So then you have to buy a separate hardware and plug it in that did the floating point instructions. So do that, because that was so hard. And one of the designers for that thing, he came in He designed a calculator for HP, and one of his first advice was you should make the floating point number decimal, because it's going to be a huge hassle if you don't. But then he said, Intel at that time, according to him, I don't know if it's true, we do it next version. We don't have too far the line. And that's now 40 years later, it's never going to happen. And it would have been a little bit better.
Would it? For sure? Like,
when dealing with numbers that humans deals with,
Yeah.
like 0.33 and 0.99, what happens when you use a binary number, like numbers in JavaScript and numbers in many systems and shaders, you introduce a small rounding error.
Yes.
And when you're doing ERP software and you're doing accounting, what you often want to do is you want to add these up to 0. And when you add things up to 0, if you have a lot of rounding errors, what happens is you get a small thing that it doesn't become 0. And then the accountant gets upset.
Yeah.
And calls the support saying, it's not 0 here, and it should be 0. I'm super angry, because for an accountant, as far as I understand, this means if it doesn't add up to 0, something is wrong, and I need to find it. And what they do sometimes is that they spend a week to try to find this problem, and then they realize, if I do this on my calculator, this works. Why can't this software just calculate correctly? We use double internally.
This whenever I like started getting into .NET was what people kept telling me about why I guess C# is superior to JavaScript because of the way that it handles numbers. But you're telling me that there's an even better way to handle numbers? C#
has a decimal data type, which is...
Oh, they do?
Which is a little bit better.
But C++ doesn't?
No, C++ doesn't,
Okay.
But there are libraries, and there are libraries to JavaScript as well, right? That use it, but it's so rare. But JavaScript actually got a very important addition lately, which is called big numbers or big integers. And if I would design an ERP system in JavaScript these days, I would probably choose big ints and say all my amounts are multiplied by 1 million. So 1 million is $1, for example. And then do it like that. And sort of, because then I can have pretty exact math. I will have some rounding issues, but I can probably handle them.
Yeah, Thindel is saying that decimal has no rounding errors, but it's a lot slower than a float. And that was one thing that I learned early on, because I was like, if it's so inaccurate, why don't we just use decimals everywhere?
Because it's not in hardware. There's no CPU instructions for it, right? But decimal, I'm not going to pick on Thindel here. Sorry, Thindel, but I'm not picking on it. I'm just pointing out the thing, and that is, if you divide 1 by 3 in decimals, you get the rounding error, because 0.3333333, this is an infinite series, cannot be exactly represented in decimal either. But what decimal can do is that if you type this costs 0.99 cents, that is stored exactly like that, and not 0.9899999967 or whatever it is, right? So, but to coming back a little bit to that thing, is there something better? Well, I think a pretty cool way to build ERP systems where you deal with these kind of things would be to use rational numbers if you use them in schools.
Are you saying we can use those here?
You can use them in JavaScript, for example. So in JavaScript, you have these big integers, right? So instead of sending a big int around, you send two big ints around, which is, I don't know what's called, but you have the top number and the bottom number. So then you can actually represent 1 divided by 3 as two numbers, 1 and 3. And then you can represent 4 divided by 3 as 4 and 3. And you can represent every rational numbers exactly that, and don't have that. And then you implement multiply and use strings. That's also a good idea, right? Then you can implement these operations like plus and multiply on rational numbers, and then you won't have rounding numbers on rational numbers. Unfortunately, there's something called irrational numbers. So, and they can't be exactly represented in a rational number. So, kind of screwed.
I don't know what 5e7. Do you know what 5e7 is? Do you know what that reference is?
I think I'm not exactly sure what he refers to, but this is notation, right? Saying This is 5,
5 to
0,
the 7th.
0, 0, 0, 0, 0, 7 zeros, and then 5. I'm guessing we're running out of time, but can I just mention a little bit about this code we did?
Yeah.
Before?
Do you want me to plop it back up? I've still got it.
Yeah.
Let me find.
By the way,
it.
Yeah, nothing. Yeah. So what I just want to show you here now is before the compiler inlined it, and it was smart enough to sort of realize it. But now we call this function, and it does the computation and puts the result in EAX. So typically, EAX is the return value of the function. And it's typically for C-like languages that you only return integers, kind of a little bit like that. So what happens when you execute this line is it's going to compute RCA, these registers, and put it in X, and then it's going to call ret. And then it's going to return to where it was before. But how does the CPU know where it was before? So we call this, so if you step this with F10 or F11, and then you step this means return to where you were before.
And wait,
now
we're about to
back.
move.
Yes.
Okay.
So what happens here, and I don't think we have time to show it, but when you say call, we don't only jump to this place, but the CPU stores the return place, the return address on something called a stack. And the stack is where all local variables and things like that is stored. And then when you hit ret, the CPU loads the return address from the stack and jumps back. So
do you know why all of these are so short? Why couldn't you type out move? Why couldn't you type out return? Like, is there a limit to like these variables?
I think if you imagine like 70s when this kind of thing started, the screens maybe were 40 characters wide. It could be something like that, right? But I don't know.
Yeah.
These days it's kind of pointless.
If this is move, what's this leave or what's this?
LEA? The one. It stands for load effective address.
It's an acronym. Of course it is.
Yeah,
And then do you know what ZOR is? Is ZOR short for something or is it an acronym?
Sorry?
The XOR but on this last line?
The XOR, that's an exclusive OR. And that is a peculiar, I don't know how to pronounce it. A weird thing about the x86. And what it does with this EX is that, you remember we said return 0 at the end of the code line, right? So return 0 means that we should put a 0 in the EAX registers because we return values in that.
Oh my God, it's actually putting the 0 somewhere? I just assumed it was like a shortcut for just ending. End it.
Yes, but what EAXOR with itself is that it makes a 0. Whatever EAX is, it will become 0. And there is an instruction that says move 0 into EAX, but that is slower than XOR itself. So this is a pattern of the x64 CPU that's been here since as far as I remember. And every x64's x6 program, they just read this as clear it. That's what it means. It says
is XOR only used to put 0 in the EAX registry?
No, because exclusive, you know there's operations like and OR, and there's also something called exclusive OR. So an exclusive OR, I'm not just stop me if you know already, but if it's 0, if you take 0 and 0, it becomes 0. If you take 1 and 1, it becomes 0. If you take 1 and 0, it becomes 1, and 0 and 1 becomes 1. So what it does, if it tests the 2 bits of the numbers, numbers of bits, if they are different, it will become 1. If they are the same, it will become 0. Okay. And this is sometimes useful. But since we're doing XOR with ourselves, we are XORing a 0 bit against a 0 bit and a 1 bit against a 1 bit. It will always be 0. And the only reason you do this is because it's slightly faster.
Can I return a 1?
Sorry? Yeah, you can return a 1, but you can change that to that.
But and it would still end. It would still clear.
It won't do that. Then it will. We can see what happens. Shall we try it?
Let's see what happens, because I thought, based on what you just told me, it would still clear. Because then it puts a 1 and a 1, and then it still turns to 0. So then
that's right. That's how you see what happens. So what we were suggesting, return 1. To stop and start again.
Brush.
I don't know what the add instruction means though. So So, and then but what you should do next time, Alyssa, when you're streaming with Ed and Alyssa, you hit Control-Alt-D and say, let's read the assembly code. And they go, then they'll be impressed.
It means to add 2 registers together.
Yeah.
Oh.
But if you step down here.
Are we? Yeah, I want to step. Where's my other brush? I don't know. I don't these step buttons.
Yeah, step.
How far am I going?
3 more steps at least.
There's my return 1. Wait, do I need to go back?
Yeah, but what happens is just below the screen, so you have to scroll down.
Wait, down here? Wait, what?
What? Here, right? Yeah, there you see. So there it says move EAX1.
Oh,
that means move.
My scroll is opposite of what I have on my Mac. So
it's unnatural scrolling. Move
EAX1. Wait.
So that means when you said return 1,
we got rid of our XOR. No. Yes.
Yeah, but that was before when you said return 0. What it means is EAX, when the function is done, should contain 0, because that's where we return values in the EAX register.
Hang on, can you say that sentence over again? You said what it means.
When you type return 1, it means the last thing we should do in our function is put 1 in EAX, because the function that checks the return value is going to look at EAX. Should we try it again?
I'm just trying to understand why we didn't get... I just really thought we would see the same thing that we had for return 0 XOR, but instead of putting 0 into the EAX twice, it was going to put 1 into the EAX twice, and it did not even do that at all. No. So I'm very frustrated.
So a more natural code, a code that would make more sense is if you return 0, you would type move EAX 0. That would make sense.
I see what you're saying. You're saying they overrode the normal flow of like...
They have a special case for 0 because it's slightly faster, a nanosecond or so faster.
I get it. I get it now. I see. So XOR is slightly faster than doing this move EAX 0. Okay. Yes. And since I assume they wanted people to be able to clear often, and so it's just...
C++ is much like that. We should make everything... We should make sure the code runs as efficiently as possible. That C++ is very much in that motto. And if the compiler strives to sort of eliminate unnecessary CPU waste.
Is it ever a problem, like, do you ever need return 0 to do the move EAX, 0? Like, is it ever a problem in programming? Like, or no, that's never, like, is it a problem that it shortcuts to XOR?
This is kind of like if we go in crazy town with our code.
I like to go to crazy town.
Yeah. But this actually happens inside the GC and the jitter of. So here's the thing: if we for some reason want to change the assembly code in runtime, so it's sometimes 0, it's sometimes 1, it's sometimes 8. Then what happens here is that it's hard to see right here, but XOR is much shorter in bytes than move EX1. It takes less space. So if you try to make our code dynamic in this way, that we sort of change the assembly code in runtime, we will cause a crash.
You will?
Yeah.
Why?
Because then we if it's XOR there, we're putting in the move instruction, and then we're assuming it should be a move instruction, but we're overwriting the next instruction with lots of garbage, and the CPU goes, I can't interpret this, and crash.
Oh.
So yes, in that sense, but that code is quite uncommon.
Did you see what Thindel said? Martin, if you don't use the return value from the function, will it just do a ret no matter what is in the EAX register?
Yeah, I think that is what is happening in Thindel. We could, of course, try it to see what's going on, in that we make a void return and see what the thing does.
Actually say this.
Main, you see, the main function is special.
Main is special. I can't return void in my main.
So it's special, but we can change our testing function.
This one.
So now we're going to make it an ugly hack here.
My decal spec.
Yeah, this here. So what I'm going to suggest is you make a global variable.
Oh, okay.
This is, good advice in general. So you make a global variable, let's call it G, and put it outside the int function.
It's yelling at me. I'm trying to Control Z, and it keeps making a Windows noise at me. What is?
So what I'm going to suggest is you take back A.
Oh, is it because I didn't stop?
Might be that, yes.
That's why. Okay, it won't let you Control Z when you're in.
So I'm going to suggest you type G equals A plus B.
Oh, okay. Not return yet.
Yes.
Yes, return.
No, remove return.
Okay.
And instead,
I can't. So you're saying that would not work?
that will not work very well. Oh, it actually will work, but confusingly so. And then you change int testing to main, to void. Sorry, I said wrong thing.
Wait.
No. We should
Void.
make this a void function because Findel asked about that.
Void function.
And now we can talk about category theory, but that doesn't work. So just remove that line.
What line? This line?
Return void. What you type should work, but it doesn't.
Oh, so what do we do?
Just remove. You can type either return or just remove it, but I will just remove it. But now you have to declare a global variable called G, and then you write it outside the function testing.
Can I just int G or what?
Yes, exactly right. So instead of returning the value in the function, we're now going to write it to a global variable, and then we're going to read the global variable and return it. But then we can see what Findel asked. Sorry,
okay.
Am I moving too quick here?
No, it's giving me errors, and
it's giving errors, but we're going to fix them. So now you just call, if you remove int x equals testing, because that doesn't work anymore. No, you keep just int. Sorry, I went fast. You remove int x.
You just still call int x.
Yeah, I want you to call the testing function like you did before.
I gotcha. Testing. Boop boop boop. And he doesn't take any. Does he take parameters still? He does.
Yeah, so it takes. We only change the return value.
Gotcha.
Yeah. This is kind of like don't do this at kids' home, like using global variables. But you have to use A and B because otherwise you can optimize it away because it's very, very smart. And then you type int x equals G to read the global variable. And now I'm going to run it again. If you close it and put a breakpoint on.
Oh, right. Which does it matter where it goes?
On line 24, I would put the breakpoint.
Okay. And then you can, there we go. And then press play, and then we're gonna open you.
Okay. And then you type F11, so you do the call.
Did it work? I pressed F11.
Yeah, so we go into the call. You see again and again, 2 times. Yeah, what does it do here? Return 0. What did it do? It looks like it didn't do anything.
Did it run?
It looks like it's just returning.
The void?
Maybe we did something wrong. Global variables are hard. That's what it says. Maybe someone in the chat has a good. Let's continue and see what happens.
Okay. Keep stepping through.
And then it loads the G pointer. And then it prints it. Let's see what it prints. But But I think Findel is right in that if you just do return, it's not gonna. The EX contains garbage. I think that is what is going to happen, but I don't know. Kids, try this at home to see.
Findel said, "I broke Martin. I'm sorry."
It's easy to break me.
This was so cool. Yeah. Napalm was saying JavaScript girl in a .NET world, not today. I don't know. I kind of feel like this stuff is definitely, this low-lying stuff is definitely, I mean, it's not on at least the average JavaScripters side of the world. If we had to categorize what we learned today, I would definitely put it in the .NET bucket and not the JavaScript bucket, but
Yeah, probably.
maybe I'm wrong.
But when you're
protection.
calling a function in JavaScript, in the end, it's going to be boiling down to what you're doing here, kind of. So what we're doing here is we're removing all the abstractions of .NET and JavaScript and whatever. And we just, okay, let's look at how we talk to the CPU, because we're talking to the CPU directly here. It's you and me now, the CPU that's communicating, mind meld, kind of. When we're doing in JavaScript, these kind of things happens, but we are kind of like, I don't know, it kind of works until it doesn't, because certain bugs you can have. So when you're doing concurrency and when you're doing threading and when you're doing high performance, like really top-notch performance, and usually when we write code, we write bad performance. I write bad performance. My code usually is bad, but it's good enough. But if I want to go top-notch performance, then suddenly all these abstractions in JavaScript and C#, they just hurt you. Because I need to work around this issue in the compiler to communicate with the CPU in the best way.
Is the option to just like not use that compiler? Like, so.
Yeah, I mean, sometimes it's just nice to, and I think sometimes that's why people are using C and C++, because they just want to go sort of, get to this, as close as possible to the metal, kind of, and without this abstraction, because they are not helping in this situation. So, but for most of us, JavaScript is fine. I kind of like JavaScript as well. So, JavaScript has many haters, but I like writing my shader stuff. I talk about my shader stuff. I've written a special JavaScript library to run shaders in the browser. So.
Oh, that's so cool. Yeah, I really.
That was fun.
I'm having fun in both worlds. I don't know. I don't really. I love JavaScript and I love Angular, and that's where I was born. But I don't know. Learning about everything in .NET has been a lot of fun so far. So I don't really understand still why there's so many. It's very polarizing.
But it's always been like that. So
I know, but why? It's just silly.
I don't know why. But when
it's all code. It all has pros and cons, and it's all fun to me. So I don't know.
So not boring about my history again, but when I was Atari guy, I was Atari, right? I hated Amiga. Amiga sucks. And the Amiga people, they were like, Atari is a worthless computer. And even today, I have a hard time admitting to myself, but I should, that Amiga hardware probably overall was better. But it still hurts, like a few years later. Because it's better. And I don't know why. It just...
Bindle said I'm getting my mitts in all the worlds now, not just both. And also coding in BF. Do you know what BF is?
Actually don't.
You have to tell us. You have to tell us.
Formatting.
Bad formatting.
Brain F. Oh yeah.
I'm so special. I like the cultural references, just like...
Yeah, but I didn't get it. But brain... I'm claiming that brain F, I don't want to say the word, it's a kid, the family is safe stream, right? That's why we're doing assembly programming. And it's not so hard to write, but it's a real pain to read.
Honestly, I feel like it would be really easy to just screw something up.
Oh yeah, but
just really mess something up.
Brain F is a joke language. It's an esoteric language. It's designed to confuse. But you should go, if you can Google if you want to do it, you can Google for a language called Piet, which is one of my favorites. Oh. So if you Google for Piet and esoteric language.
How do you spell that?
Piet.
Have you you used to write it?
It's an artist called Piet, but it's a programming language named after artist.
A stack-based it's actually esoteric is in the name.
If you click images, you will see.
Images.
That's the important thing about the language.
Image. Here, let me
share the screen.
Yeah, I'm gonna try to find the button. Where's the button? There's the button. So.
Oh, that's a programming language. All of these pictures are the Piet images here. This is an esoteric. That's a language. That's a programming language. You program in pictures.
I'm
So
super
these things-
confused.
Yes.
Are we using esoteric not in the sense of really old and outdated
It's
and
weird.
unknown?
It's created as a joke. There's also Shakespeare programming language where you define variables by using Shakespearean insults. You are as blah 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 as a pig, as whatever, and that's how you define a variable. And then all variables has to be characters from the Shakespeare play. So they need to be named Hamlet. I don't know what Ophelia. I don't remember all them, right? But you can't. All variable names has to be characters in that, and in order to push to a stack, you sort of I don't know. It's weird.
That is funny. HTML with hello
word source. Yeah, it's a HTML probably.
Oh, go back. Give me this one.
Yeah.
Hang on, let me
You
zoom.
lying stupid.
Oh, I'm back. There we go.
Romeo, a young man with remarkable patience. That's how you declare a variable.
Oh my
Romeo,
gosh.
variable. Juliet, a likable woman of the scruple. And then you have different acts.
Goodness.
This prints hello world.
Oh, the things that people come up with. I'm actually really interested in I don't know why I'm so large. There we go. In the esoteric languages. That sounds so cool.
The most classic esoteric language is intercal. That might be one of the first ones. And one of these main features this has is that it make, go to is bad, right? That's what we all learn. And that they took it to the heart. Yeah, go to is bad. So instead they implemented come from, which means that you type come from 100. So when you hit line 100, it jumps to a come from line. It's kind of the reverse of go to. So if go to is bad, come from must be good. What is this?
Someone sent me rockstar.com, code with Rockstar.
I know.
I'm not really sure what I'm looking at though.
And then it's lolcats language. There's so many.
A lolcats language.
Yeah.
That is. I love it. I scroll up, Alyssa. Oh, scroll up.
Yeah, intercal is you can compile it. It works, but no human would want to write because it's absolutely horrible.
I don't know, man. Broke it or something. I'm scrolling and there's I'm gonna go to the docs. And
you have to write for another funny things by intercal is you have to type please. Otherwise, you have rude code compiler exception. But you can't type it too much because otherwise it's too sort of too pleasing.
What was this one that you just said with please?
It's intercal. And on each line you can put a chance that it should be executed. So this line should be executed 50% of the times. It should be executed 30% of the time. It's completely stupid. And I think you put in values as Roman numbers and write them as it's completely ridiculous.
I love it. And honestly, I'm so grateful for you coming on today. This has been I've had a lot of fun. I know people might be a little flustered. Don't worry. We're going to start doing some Maui and some desktop bits. But I love this kind of stuff. I really like to learn the why of things. And so this is really good. I really loved it.
I actually think in some sense, this kind of low-level stuff is simpler than Maui and Angular and these things because it's just a single machine. It's a single thing. Things are just happening. You don't have a lot of threads unless you start them. So it's the word is smaller. And it is a little bit strange and it's a little bit to learn. But with Angular and JavaScript and things, you just overload it, and then you're running on multiple machines, on Docker containers. I'm feeling I want to go back. 1998, that was a good year. So
my husband, he's the one who actually got me into dev. He's full stack, but he calls himself a front end developer, and he often will say how he misses the jQuery days. Just
those were good days.
Yeah. He goes, he's like, you just would not believe how simple they were compared to the frameworks now.
And maybe people were a little bit more focused on getting things done. Because the Cobalt guys are very focused on getting things done. I sometimes think we drown in all these kind of patterns and ideas and sort of, it doesn't scale is a very common argument when we come up with something. So
yeah, he showed me an app he wrote it was before frameworks, before Angular, before React, and he wrote it for TVs to run on It's like an Apple TV, but not for Apple. I don't know what those boxes are called. I don't remember what they're called.
TV box. I don't know. TV.
Yeah, and it was one line. Like it was JavaScript, and it was one file. And he was like having to even things like catch like events from like the remote click and like it was super. I was just like, wait, how did you organize things? You were in one file, like what? Like
yeah, but that's the F# way. One file. You don't need more than one file.
Does F# do that?
I think F# developers are more open to the idea of stacking functions and things that belongs together. In F# projects, I think you see fewer files. But you know what they say now, Microsoft, with the minimal API? We should put everything in program.cs. I'm pretty sure that's what they say.
Is that a say? Is there?
No,
So Layla was telling me about minimal APIs, and I was just like really trying to keep up. She was so excited about it, and whenever I first heard of it, I was like, I still don't really. I don't get it. I don't understand it because I thought it was super simple, and then she started talking, and I was like, "Oh, this is not at all what I thought minimal APIs were." So, are they only in? It's a C# thing.
No, not really. I mean, in F# has always had. I mean, F#. Now I sound like this arrogant F shopper, right? Because F shoppers are known to be arrogant. I watch Twitter. I know what the people. I know what we say.
You're like, I know what those F sharpers are like.
Yeah. So we are, but it's this kind of minimum API is not. It doesn't feel very new for a F# developer. It's kind of the thing. But here's another thing, right?
I think Findle does not want you to put everything in one file. I think
that's what they say. But what they're really saying is they want us to put everything big file. No, but I think what we're seeing now is kind of this thing that Java, when Java came out, it was a huge feature of Java that everything has to be a class. So in order to make int main, like the main function, you have to put it in a class. This is excellent because now you're forced to write object-oriented programming, and object-oriented programming is what's going to save us from bad code. That was kind of, I'm paraphrasing it there, but so then this was a good thing. This is how it should be. But now we're removing this class and we're removing the main function. We're going back to kind of how C looked, in my opinion.
It's funny the pendulum just swings, back with everything though, not just with like syntax and programming, but even UI. Like I've seen it start to swing back, and it's it's funny to me. Sorry for taking too much time. I cannot believe I met another. I mean, you're not chaotic evil, but lawful. I feel like we're still on the same side of the.
I can probably turn you lawful.
Probably with all of this programming background now, because that was pre-dev Alyssa. So
but I think most F# developers are lawful evil. So
Oh, that actually, you should tweet that. I need to retweet that.
JavaScript developers make sense. Chaotic evil to me.
I honestly think that's true. We should make a little table of what developers are, what class, line it up. Thanks, Findle, and thank you everybody in chat. This was super fun. Have an awesome. It's Tuesday. Bye.